I've been teaching myself Spanish lately. I still remember when I first woke up from my coma. I couldn't say a single word.
That actually brings up a fascinating topic called linguistic relativity. It's about whether language shapes thought or thought shapes language. Speaking of linguistic relativity, have you heard of the movie Arrival? Let me give you a brief rundown of this sci-fi movie. The pace of the movie is pretty slow, so unless you're a hardcore sci-fi fan, it might not be your cup of tea. And for those planning to watch it, beware of spoilers. The plot isn't very complicated. It's about humanity's first contact with an alien civilization. The protagonist, Dr. Louise Banks, is a linguist and a university professor. One day, 12 alien spaceships suddenly appear on Earth. To prevent unnecessary conflicts, the US military invites her to try to communicate with the aliens. Louise, along with physicist Ian Donnelly, enters one of the spaceships.
Look, they're also a male-female team like us.
Yep, each has their strengths. Once inside the spaceship, they encounter aliens behind a huge glass wall which look like octopuses. Our octopuses have 8 legs, but these aliens have 7. The idea of octopus-like aliens is quite intriguing and appears in many works, like in our discussions about Europa, the moon covered with oceans. Some sci-fi fans imagine it teeming with octopus-like creatures, just like in the Europa report. The genetics of octopuses are pretty unique too. We can dive into that in another lecture. Back to these aliens, they write in a strange circular script on the glass. The complexity of their language makes progress slow. As Louise becomes more familiar with their writing, she starts to see some imaginative visions.
Question. Why don't aliens learn our languages?
Well, their languages contain more information than ours. As the world situation becomes increasingly turbulent, the suspicion among countries also gradually deepen. Later, the US military secretly placed a bomb in their spacecraft. The aliens sense the danger and, after conveying their final message to Louise, protect her and Ian, sacrificing themselves. Ian then realizes that the circular script contains spatial information.
Ancient Earth languages were also three-dimensional. They were carved into stone with depth.
Personally, aliens' language suggests that they might exist in higher dimensions. It later turns out that by mastering their script, one can change their cognitive processes. Eventually, Louise gains the ability to perceive time differently, experiencing the past and seeing the future. This concept mirrors the Sapir-Whorf hypothesis. American linguist Benjamin Lee Whorf believed that language shapes thought and our perception of reality. In linguistic relativity, language influences how we encode, present, and recall information about the world. An extreme view is that language determines thought. Without language, there's no thought, and its characteristics dictate what we can think about. However, as thinking beings, we don't always use language in our thoughts. For instance, solving a geometry problem involves visual and spatial reasoning without words. There are many similar examples.
When I woke up from my coma, I knew what I wanted, but I couldn't express it in words.
Many scholars disagree with the idea that language determines thought. For instance, Soviet psychologist L.S. Vygotsky and Swiss psychologist Jean Piaget believed that thought precedes language. They argued that cognitive development in children influences their language development. For example, children need to understand the concept of possession before they can use possessive pronouns. Soviet psychologists A.P. Luria and Anne Leontiev argued that while consciousness relies on language, its roots lie in the interaction between humans and the objective world, not in language itself. Our ancestors didn't have language, yet they clearly had thought processes. The creation of tools and the conduct of various activities reflect their thinking. We see this in everyday life too. Babies smile at their parents and cry when they see strangers. They use gestures and facial expressions to communicate their thoughts. This shows that thought precedes language. Humans have an innate physiological basis for thought even before they develop language.
So, does learning multiple languages expand our thinking?
Great question. Let me share a real story. In 2022, a Washington Post article surprised many people. If you hired a carpet cleaner in Washington, D.C., you might meet someone who can negotiate with you in 24 languages. In an international city like D.C., an interpreter fluent in just one foreign language can earn a six-figure salary. But this carpet cleaner spent most of his life in obscurity, earning less than $20 an hour and living with his mom well into middle age. This hidden master is Vaughan Smith, who gained recognition for his linguistic abilities. Vaughan modestly claims he only knows 24 languages, 8 of which he speaks fluently at a native level. People who speak 2 or more languages are called polyglots. For someone like Vaughan, linguists use a special term, hyperpolyglot. In linguistic research, knowing 6 languages marks the threshold between a polyglot and a hyperpolyglot. There are very few hyperpolyglots in the world today. According to University College London linguist Richard Hudson, about 30 people worldwide claim to speak more than 10 languages.
Is his brain different from others?
Researchers are curious about that too. Evelina Fedorenko, a neuroscientist at MIT, has been studying polyglots, especially hyperpolyglots. She, along with Harvard neuroscientist Simon Malik Moraleda, used functional magnetic resonance imaging, fMRI, to scan Vaughan's brain, observing his brain's reactions when he hears and speaks different languages. We've mentioned fMRI in previous videos. It measures the blood oxygen levels in different areas of the brain. You can think of blood oxygen levels as reflecting how hard neurons in that area are working. The more effort, the higher the oxygen consumption.
I guess Vaughan's brain must be super active, so his oxygen consumption must be really high, right?
Actually, Vaughan's brain seems quite calm. When he hears any language, his brain's oxygen consumption is much lower than that of an average person. Even when listening to his native language, his brain is much quieter compared to others who speak the same language. This makes sense if you think about it. Vaughan's brain is so efficient that it doesn't need to work hard to understand languages, so its oxygen consumption is lower. It's like how a high-performance motherboard doesn't heat up easily. Similarly, athletes often have a lower resting heart rate than the average adult. Of course, when polyglots encounter unfamiliar languages, their brain activity does increase. However, compared to people who only speak 1 or 2 languages, the increase in neuron activity is smaller. In other words, their brains are more efficient at processing foreign languages, requiring less energy. Interestingly, some studies show that in cross-language tests, some bilingual students have increased reaction times and errors. They point out that switching between languages can require more mental effort and attention, triggering more brain activity.
This guy must be really smart. So is there a link between language ability and IQ?
Actually, that is hard to say. In 1991, researchers reported a case of a man named Christopher. This unfortunate man was diagnosed with brain damage at 6 months old. Even as an adult, he couldn't take care of himself and had to live in a psychiatric hospital. However, Christopher had a unique ability. Despite having a non-verbal IQ below 70 and a verbal IQ of just 89, he learned 16 languages, making him a true hyperpolyglot. Researchers believe Christopher might have had Savant syndrome.
Wait, what syndrome?
It's similar to the movie Rain Man.
You memorize the whole book? You start from the beginning?
Yeah.
How far did you get?
G. Patsy. William Marshall Patsy.
I'm curious, I hope it doesn't offend you. Did you notice any special changes on yourself after waking up from your 13-month coma?
I feel like I can see things that don't exist in reality.
Savant syndrome refers to individuals who have severe intellectual disabilities, autism, or other psychological conditions, yet possess an extraordinary talent that contrasts sharply with their disabilities. There is also a second type called acquired savant syndrome. Acquired savant syndrome often occurs after a head injury, leading to exceptional abilities in mathematics, music, or art. As early as 1789, scientific literature described this syndrome. The father of American psychiatry, Benjamin Rush, once described Mr. Fuller, a mentally ill man with rapid calculation abilities. When asked a complex math problem, Fuller quickly provided the correct answer. There are many such cases. Over 20 years ago, there was an American named Jason Paget. One night in September 2002, after leaving a karaoke club in Tacoma, he was attacked by a gang of thugs. They knocked him down, kicked him in the head, and stole his $99 leather jacket. Paget was taken to the hospital unconscious, where doctors found he had severe brain trauma and a concussion. After being discharged, Paget noticed his vision had changed, and he began to see details he had never noticed before, like watching water flow in a bathroom for hours. Most incredibly, he suddenly developed a talent for mathematics. He could see complex mathematical formulas everywhere and even draw intricate geometric patterns to represent them perfectly.
Maybe I have awakened some kind of savant talent too.
There are indeed many mysteries about the brain. We've previously discussed the sci-fi movie Lucy, starring Scarlett Johansson, which explores similar themes. We could dedicate a lecture to the awakening of savant abilities in the future. Now, back to the topic of hyperpolyglots. Simon Fisher, a geneticist at Oxford University, discovered in 2001 that language ability is linked to specific gene segments. This suggests there might be a language gene that determines one's proficiency in multiple languages. In fact, many animals, such as songbirds, have similar language genes. In humans, mutations in these genes can lead to speech disorders like verbal dyspraxia, where individuals cannot coordinate their speech muscles and therefore cannot speak. Some researchers believe environmental factors contribute to becoming a polyglot. Lorraine Obler, a neuroscientist at New York University, suggests a theory that links polyglot abilities to the uterine environment during fetal development. If during pregnancy there is a surge in intrauterine testosterone, then the asymmetry of the fetal brain will be enhanced. In the future, this child is more likely to become left-handed. Correspondingly, the likelihood of the child developing autoimmune diseases and learning disabilities increases. Research also showed that these kids have higher chances to be homosexual when they grow up. At the same time, their abilities in art and language will also be enhanced. This theory aligns with Hudson's findings. Let's get back to linguistic relativity. There's a famous case in medical history known as the case of Monsieur Tan, whose real name was Pierre Le Borgne. He was a French craftsman who suffered from epilepsy since he was young. Around the age of 30, he lost his ability to speak and could only produce a sound similar to tan, earning him the nickname Monsieur Tan Tan. In 1861, he was referred to the famous neurologist Paul Broca at the Bicêtre Hospital in Paris, which marked the beginning of a revolution in brain science. Broca discovered that Le Borgne had no intellectual issues. He could understand language and read, but he couldn't speak words. Drawing on earlier examples reported at the Paris Anthropological Society, Broca examined Le Borgne's brain and pinpointed the damage to an area near the third frontal convolution of the left hemisphere. Broca concluded that this area was the language center. He carefully collected more cases to support this, and by 1865, he boldly and clearly stated that the two hemispheres of the brain have different attributes, a revolutionary idea at the time, with the language center located near the third frontal convolution of the left hemisphere.
So, before language evolved, what were these brain areas originally for?
Good question. Let's explore the origins of language. There are many hypotheses about how language originated. The Bow-Wow theory suggests early words were imitations of animal and bird sounds. The gesture hypothesis posits that human language developed from gestures used for simple communication. The tool use hypothesis argues that language evolved due to the use of tools. We'll focus on the gesture and tool use hypotheses. Both suggest that language originated from certain bodily actions, which makes sense since controlling gestures involves brain activity. In a broad sense, speaking can be seen as a type of gesture. Our ancestors' brain language areas were likely responsible for these functions before language developed. An interesting phenomenon is that brain imaging shows different areas are activated when speaking a native language versus a second language. The superior temporal gyrus is crucial for language learning, activated during native language use for automatic processing of vocabulary retrieval and phrase construction. The superior temporal gyrus's activity is much lower when using a second language, with the brain mobilizing more resources from other areas to decode it, including the inferior frontal gyrus, which engages consciousness in understanding words and sentences. If a person speaks multiple second languages, they all use this system. People who learn second languages faster have anatomical differences in their brains. For example, the morphology and size of the auditory cortex can reflect one's ability to comprehend a second language. Connections between the auditory cortex and specific parietal regions can indicate one's ability to speak a second language. When using a native language, we rarely rely on conscious decisions about word choice and grammar, allowing for smooth and coherent expression. In contrast, using a second language involves conscious adjustments, making it a time-consuming and effortful process. Hence, achieving fluency in a second language comparable to a native one is challenging. Infants and toddlers learn languages over a long period, relying on a highly plastic young brain and social interactions. As myelination improves signal transmission speed between different brain areas, it gradually reduces neural plasticity. As we age, learning a second language becomes a consciously supervised knowledge acquisition process, making it increasingly difficult, with a more pronounced accent. Research shows that learning a second language before the age of 7 usually doesn't result in an accent, but if social interaction is hindered by conditions like autism, it can severely impede language learning, including the native language. However, this doesn't mean it's impossible to learn multiple languages later in life. Some scholars point out that actively learning multiple languages can benefit the brain. Bilingualism can delay diseases like Alzheimer's and dementia by up to 5 years. In summary, whether someone is suited for learning multiple languages is related to specific language genes and shouldn't be forced. Actively learning multiple languages might not make you smarter, but it can make your brain healthier and more focused. Like athletes training their bodies, training your brain can lower its oxygen consumption over time. Who knows, mastering an alien language might even let you foresee the future, like the protagonist in Arrival.
Hey, you! Don't play games. I know you're watching on the other side of the screen. That's right, freak. It behooves you nothing to ignore me. Join the lab and become Labman 000X today. Today's keyword is